Okay, so um, calculus, uh, calculus is very simple. So normally, what comes in an exam, there is mathematics paper one first and foremost. Let me just introduce differentiation before I come to integration. So differentiation is the first concept that you have to do when you want to actually answer calculus questions. Because a background is very important. So once you identify indices, if you did indices and you know how to answer indices, then it will be very simple for you to answer calculus questions under differentiation. So the basic key, actually grade 12 level, they have introduced calculus. So calculus normally is very simple. There is no need for me to start identifying what is calculus and other stuffs. No, what's important is just to go straight to the point. So under calculus, there is what we call differentiation. So when you talk of differentiation under calculus is very important, where a learner has to understand this one. Because when you are differentiating, we differentiate with respect to something. When you are differentiating, we differentiate with respect to something. So now, when you want to differentiate, we do not just differentiate anyhow, but actually we are going to use an expression. For example, if you have been given an expression to say ax raised to the power n, you see, this is the given expression. When you do not have an equation, we call it an expression. But once you inculcate an equation, we call it an equal sign, we call it equation. But this one is an expression. So when you have been given this one as ax to the power n, we call it expression. So under indices, we used to say this one, we call it as a what? Or a coefficient. So when we talk of a coefficient is a number in front of a letter, or a letter multiplied by a number. We call it a coefficient. So when you talk of this one, x, this one we call it a what? A variable. This one is a variable. So x is a variable. So for instance, if we have x here, then we have 4 here, then you are told what is the coefficient of 4x, which is the 4, because a coefficient is a number in front of a letter, or a letter multiplied by a number, we call it a coefficient. Then this one, we call it as what? As power. That is power. So when you are differentiating, you differentiate with respect to x, or with respect to the variable that has been given in that expression. So in full now, when you have been given y is equal to ax raised to the power n, hear me correctly. When you are differentiating this one, if you are taught to differentiate y is equal to ax to the power n, you are going to differentiate with respect to what? To x, where you say the derivative of y as well as the derivative of x. So we differentiate as usual using dy over dx. So since we have y is equal to ax to the power n, so you're going to say, if you want to differentiate this one, you differentiate with respect to x, this one. So you're going to say dy over dx is equal to, then when you want to differentiate, hear me correctly, when you want to differentiate, we say we have this power, which is the power multiplied by the what? The coefficient. So we are going to say a times n. What is a times n? You say a n. You see? Then x, you bring the way it is. Then when you are differentiating, we reduce to 1. You reduce to 1, meaning the power here, you reduce it to a t to 1. So you're going to say n, you reduce it to a t to 1. So this is the formula that we use when you are differentiating. So we say you multiply a times n, which is a n, then x, you bring x the way it is, then you have power n. Now you reduce this one to 1. So we reduce to 1. So when you are differentiating, we reduce to what? To 1. So therefore, the formula that we use when you are differentiating is dy all over dx, which is equal to anx n raised to the power 1. So that is how we use this formula. So for example, if you have been given let me say questions example, like you've been given questions like let's say 4x power 2 then plus 200, then c you say 1 over 3x then plus 5x to the power 4 plus 5x then plus 100. You see? Yes. So if you have been given this one, you've been given this one, that is, so if you want to answer this one, it is simple as drinking amenshi. So simple as drinking amenshi. Then D, I also put 500. So you see, so when you are differentiating these, it is as simple as drinking amenshi using this concept or using this formula. So you're going to say like A solutions, you say solutions, like you have A. So A in full you can write y is equal to 4x power 3 then plus 1. That is in full. So now if you are differentiating this one, you say dy over dx is equal to, now you say the power, you remember this one where you used to say n times a, so meaning you say 3 times 4. What is 3 times 4? It is 12. Then x to the power 3, we reduce to 1 when you are differentiating, so minus 1, then plus. Now remember we have 1 here. Take note, when you are differentiating the derivative of any constant number, when you are differentiating the derivative of any constant number is what? Is 0. So since we have a constant number 1 here, we put what? 0 here. Derivative of any constant number when you are differentiating is what? 0. So therefore you simplify to say 12x. What is 3 minus 1? It is what? 2. So 12x raised to the power 2. This is the answer. So that is how we differentiate. You multiply 3 times 4, which is 12. Then the derivative of 1 is what? 0. So therefore, 12x raised to the power 2 is equal to dy all over dx. That is how we answer this question. Simple as drinking amenshi. Then you come to B. B, you have 5x raised to the power 3 minus 4x raised to the power 2, then plus 200. So when you are differentiating this one, it is just the same. It is simple as drinking amenshi. Simple as drinking amenshi. So when you are differentiating this one, you are going to say you use, it is the same as y is equal to 5x raised to the power 3 minus 4x raised to the power 2, then plus 200. You see? So that's how we do it. Then you differentiate with respect to x. You're going to say dy all over dx is equal to 5. Is equal to, now you use the concept, this one, use this formula to say, now you multiply a times n. So here we have 5 times what? 3. What is 5 times 3? We have what? 15. So you say 15. So it is 15, then x. Then you reduce it to 1. What is 3 minus 1? Which is 2. Then you have this negative 4. What is negative 4 times 2? Then you say negative 8. Then x. What is 2 minus 1? Since we are reducing to 1, we are differentiating, which is what? 1. So you put 8 the way it is. Then what is the derivative of what? Constant number, which is 200. It is what? It is 0. So this is the answer. So simple as that. It is as simple as drinking, drinking. So that's how we answer those questions. So we go to the third one, which is C. D, I'm not going to answer D because D I've explained. You comment and actually give me the feedback there. That is to see if how you are following or you are not following. But I've explained D. So now you go to C. Now C, we have it is saying 1 over 3x, 1 over 3x, 1 over 3x, 1 over 3x, and then plus, what is there? 5x to the power 4. 5x raised to the power 4. 5x raised to the power 4, then plus 5x, then plus 100, plus 100. So you see this one. So in full, we are given like y is equal to 1 over 3x, then plus 5x raised to the power 4 plus 5x plus 100. So when you are differentiating this one, we follow the same concept. Now this one is different. If you can see, we have this one with this fraction. So when you remember in grade 10, if you remember indices, we were told if they were what we called positive indices and also negative indices. So when you talk of positive indices, we talk of 1 over 2, 1 over 3, 2 over 4. These are positive indices. So now, the reciprocal of this one, or let me say the negative of this one, we call them negative indices. So if you want to convert this one into negative, you say 2, negative 1, 3, negative 1, you see. So that's how it is up to the last one. So let's see how we do this. So now, since we have actually this one, so and then you want to actually differentiate this one, you can change this one into what? Into negative index, so that you simplify it. So you can say the negative index of this one, you're going to say 3, then x negative 1, that is the negative, then plus 5x to the power 4 plus 5x, then plus 100. You see? So now you're going to differentiate this one with respect to what? To x. So how do we differentiate this one? It is simple as drinking. So what we do is you're going to say dy over dx is equal to now sorry, we're going to say negative 1 times 3, which is the negative 3x. Then negative 1 as the power. Since we're differentiating, we reduce to what? To 1. Then you say plus. What is 4 times 5 or 5 times 4, which is 20. X 4, you reduce it to what? To 1. Then plus. What is 5? Sorry, you say 5 times 1 here. Since there's no number, it's 1. 1 times 5, it's 5. Then x, the one which was invisible, you make it visible, and then reduce it to what? To 1. Then plus. The derivative of any constant number is what? 0. So you see, simple as that. Then you simplify to say negative 3x. What is negative 1 minus 1? Both mass, you say negative 2. Then plus 20x. What is 4 minus 1? It is 3. Then plus, what is 5? Then x, you say what is 1 minus 1, which is 0, not so. 1 minus 1 is 0. This one, if you put it or not put it, there is no need, no problem. So you simplify to say now, since you have this one, you cannot leave this one the way it is. You are going to say negative 3x raised to the power 2, then plus 20x raised to the power 3, then plus. So you say 5, then open. Use the concept of indices where you say any number raised to the power what? To the power 0, it's what? 1. Even if it's a letter B raised to the power 0, C raised to the power 0, 100 raised to the power 0, it's what? 1. It's 1. You remember this concept under indices? So any number raised to the power 0, it's what? It's 1. So you put 1 here. So you simplify now to say, therefore, dy over dx is equal to negative, then before I put dy over, okay, I put like this, 3x negative 2, then plus 20x to the power 3, plus what is 5 times 1, which is 5. So this is the answer. Now, if you leave this answer here, it is not complete. You remember what we were given before? It was under what? In positive statement of indices. So even this one, you're going to convert back into positive indices from what? Negative. Therefore, it is as simple as drinking a mention. You say, therefore, you convert this one. Here, you have this negative 2. So this one, the positive of this one is what? Negative 2 only. You convert this one, or let me say the O of this, you convert into positive, you introduce 1 on top, then O over, meaning once you introduce 1 on top, this negative part has been has disappeared. So you're going to say now, you can put this negative here, or you say negative 3x to the power t to the power 2. You see, there is no negative here because of this 1. Mainly, if you put here negative or you put it here, it's 1 and the same. Then plus 20x to the power 3, then plus 5. You see? So that is how we differentiate this one. That is how we differentiate this one. It is as simple as drinking a menshi. So if you write this one, or you write this one, you say, since it's all of this, you can say negative 1 over 3x raised to the power 2, then plus